Okay.
My computer like blocked the website for a second. Okay. I'm ready when you are.
I am ready. So in an article in the Journal of Small Business Management, successful startup business in the United States and Korea were compared. One set data compared educational levels of people who manage successful startup companies in the United States and Korea. They want to determine if education levels of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate? Wouldn't it just be?
Well, it's a categorical one because it's talking about like high school, like the education level.
Can you hand me your computer?
So wouldn't it just be?
Sorry, I think maybe the pair.
Oh, wouldn't it be the Chi one? Because it's talking about like different countries, and it says you want to determine if the education level of managers of successful startup companies is independent of the country or they're. Oh wait, but it's only United States and Korea. Never mind.
Yeah, just the two.
So yeah, I think it'd be test of two proportions.
Let's look. See if what's it called that she has.
Oh yeah, that sheet.
Yeah, let's pull it up. So he's like at Idaho Falls.
Yeah, Valley area. So it was easier to fly to Idaho Falls than drive all the way down to Salt Lake.
Oh, really?
Yeah. It was only like an hour to there versus like 3 hours to Salt Lake, 2 or 3 hours to Salt Lake.
Does that make sense?
Would have been more convenient for me if you flew to Salt Lake, but oh well.
Oh, let's look. Oh, that has two sites. And the first one they did the try one, like you were saying.
But I think it's only a test of two proportions because it's only talking about the United States and Korea.
So with the try, there's more than one, like more than two. I mean.
I think so. Kind of my understanding.
Okay, that sounds. Okay. So a human resource manager reported data from a recent involuntary reduction in force at our company. You are an attorney and want to determine if age discrimination was a factor. The company reported the number of employees in two groups, 40 years old or younger and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? So we have the two again.
But this would be a paired sample or independent sample? Do you think?
Which one's ANOVA?
ANOVA is the one, it's
Let me write these down.
kind of like the Chi, but it's multiple samples. So the ANOVA is also quantitative and not categorical. And so that's like the first thing when I read these things, I ask if it's quantitative or categorical, because then that narrows down a lot of the choices.
Yes, very true.
And this one is quantitative, right?
If it's looking for the ages, yeah.
And so is it independent or dependent?
Well, the depend. Let's think. Where did my little? There we go.
Wouldn't it be independent?
I think because they don't depend on each other. The two companies, they're both independent of each other.
Wait, it's only one company though.
Oh yeah.
So wouldn't it be dependent? Right? I don't know.
I think it's the test of two portion.
What?
I don't know. I'm just looking at. Oh, I'm trying to pull this study guide. I'm sorry, it's still loading. So I can review it again. Would this be the test of two proportions?
No, because that one's only categorical data.
But wouldn't age be categorical in a way because it's describing?
Oh no.
Quantitative because it's not like a number of certain things. I don't know. I kind of feel like age is more like a color. Like it's describing. My goodness. Well, I don't know. What one are you thinking it is?
I'm thinking it's either the independent T sample or the paired T sample. I think it might be the independent sample T test.
I think it would be independent.
Oh well. If I get it wrong, you get it wrong.
We'll try it.
Or do we have 2 attempts? I think we had 2 attempts on this one actually.
Mhm.
You have to go at 6:45, right?
It's fine. I'll just go when I go. It's not like I'm supposed to go to work today, but no one's gonna think we're open.
That's true.
So I don't think I'll be missing anything if I'm late. And I told them I'll probably be late, so it's fine. Okay, so a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. So which hypothesis test? Test of one proportion? Mm,
Yeah.
equal to, not equal to. Oh, it makes no sense to me. Like,
No, you're right. For a second, I thought it was quantitative, not categorical, but then I reread the question. It's definitely categorical.
if you feel like numbers, but they're
What?
not the numbers. Okay, we'll try it.
Wait, which one are you putting?
Test of one proportion.
Okay, sorry. Just
Okay, 5. The student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. We asked 25 students to participate in the study. Each student was given the combination of each lock and asked to open the locks. The time it took them to open each lock was recorded. We want to determine if one of the locks is easier to open. Which hypothesis test would be most appropriate? We had
would it be paired sample t-test? Because the student who opens the first lock or the student who opens the second lock depends on who opens the first lock. Because it has to be the same student.
Would it be pendant then? Because I thought paired would have been like if they were different students.
I don't know. I get so confused on these.
Like a certain student did like the clockwise one, and then the other students did like they were two different. I think that would be more paired. But so it sounds more like an independent. Let me look at the.
Well, I think you're right. I think it would be independent.
That's what I'm like reading, because if it was paired, they would have to be two different groups.
Yeah. Whereas this one's more of like their time in one versus their time in the other.
Yeah. Oh my goodness. Okay. We'll try it.
A bank employs two appraisers when approving borrowers for mortgages. It is imperative that the appraisers value the same types of proportions or of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for the study? Would this be a paired sample?
I think so. Yeah. Yeah, I think so. Yeah. That's what I would assume as well.
Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors who were reporting satisfied with their career paths was reported. Same data was also reported for accounting majors who decided to construct a 95% confidence interval. See if the observed difference is significant, which confidence interval would be most appropriate.
No man, I do these real quick.
I think it's categorical, so wouldn't it be sample of confidence interval for 2 proportions or 1?
Mm, let's look. I think just the one.
I think it's 2, so I'm gonna put that one. But you can still put 1 if you want.
I'm trying to
Just because it,
like
the
the
reason,
confidence interval for 2 proportions.
yeah, because it's comparing the psychology majors to accounting majors.
Oh my goodness, I didn't even see that. For some reason
That's what makes me think it's 2.
yes. For some reason, I just read that there was like psychology majors, just seeing if they were happy.
Oh, then yeah, that'd be 1.
Well, then yes, definitely 2. I am not a morning person, if you didn't know that.
It's okay, neither am I.
Okay. Oh, Oreos. Okay. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is true. Assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true filling amount of double stuffed Oreos in order to compare to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? So we're only comparing. So at first, we're only finding the true mean filling amount of the double stuffed Oreos right now, right?
Yeah, I think
That's all
so.
we're doing. So it would just be the one sample as of now, because we're not comparing it yet to the regular Oreos.
Is it 1 sample T or Z, though?
That's what I'm debating right now. Because Z. One sample z-test is when the population standard deviation is given. So I don't think that was given, so it would be the one sample
Sample
t-test.
T? Yeah, okay. I hate these questions.
Me too, so still going. Okay, which of the following best defines the notion of significance level of a hypothesis test? I feel like this was on one of our homeworks.
I think this has been on like 3 of our things. I think it's the first one.
Mm-hmm. Yep. Okay, so which of the following best defines the notion of the p-value hypothesis test?
I lied. I think the p-value is the more extreme.
Let's look.
I think the hypothesis is
I found the definition p-value, the probability of obtaining a test statistic at least as extreme as the one you calculated.
right. So that means the other one above it, number 9, is wrong.
Okay, so let me find the hypothesis test. Example of hypothesis equal to, not equal to, or something like that. Um, probability of a type 1 error. What does that mean again? It's like, oh, type 1 error is committed when we reject a null hypothesis that is in reality true. Type 2 is when we fail to reject.
Oh, I found. Okay, so the significance level is also is the probability of rejecting the null hypothesis when it is true. So that would be
So I
option
think
C.
1 or type 1 error.
Wait, wouldn't it be option C?
Oh, well, where did that go?
Confused.
Because I don't know, a type 1 error is committed when we reject a null hypothesis that is in reality true. Isn't that what you're just saying?
Kind of, but we're just talking about this one is specifically asking about the significance level, and that's what determines if we reject it or not. Because remember, if the P is, like, we compare the P to the A, and so it doesn't mean we will do a type 1 error. It means we could do a type 1 or a type 2, which is mean it's the probability of rejecting the hypothesis if it's true or not.
Okay. I'm trying to.
Does that make sense?
A little bit. I'm just trying to find more of like a place where I can read about the hypothesis. Are you just on the review sheet?
I was starting to look at it.
Oh, okay, I didn't know where you got that. Yeah, we'll go with it. I can't find it right now, and that sounds logical. Where's my tab? I have so many tabs open. Okay, which of the following best defines an, oh, we did that one. Okay, 11. Suppose you create a 95% confidence interval for a mean and get 10, 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? I feel like we've had this one a lot. Like
I think it's the second option.
okay, hesitancy at first, like that's the first thing I'm thinking of, the 95% of all 95% confidence intervals.
Yeah, because I didn't put that one in the last time and I got it wrong. I remember that.
That's what I first went to. I'm like, I'm pretty sure that's it. Okay. Okay, so you take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is equal to 0.3 or 30%. Okay, so what's the mean? Do we need to put it into the Mhm. Why do I think that the mean is just like the 0.3? Is that?
Sorry, I'm scrolling. I lost it.
No, you're good. I remember like that being in a homework where like, oh yeah, the mean is really easy when it gives you the p-value like that. Like the mean is.
Oh, this is the little p, like you know the p with the caret and the other p?
Oh yeah.
So that's what this is. So the sample size is 100. %30 of 100 is 30.
Yeah. Mean is p was 0.3 equals p, so it'll be. I can't. I don't know. Would it just be 0.3?
Yes?
I think
I think so. Oh, wait.
30%, right?
Yeah, because it'd be x divided by n to get the true mean, but we don't have x.
Mm-mm.
So yeah, I think so.
And to find the standard deviation, like the, I think I had it. Where'd it go? Because we can't really put any of this into a Excel sheet, can we? Because we don't have enough.
I don't think so.
Oh, right here, standard deviation.
1 minus the 0.3 times the 0.3 divided by n, which is 100.
Oh my goodness. I have like the square root of p caret times 1 minus the p caret divided by 100, like divided by the n, which would be 100, right?
Mm-hmm.
Okay. Get my calculator.
Okay, I got an answer whenever you get yours.
Well, that was really quick.
Yeah, I was doing it while you were talking. I'm sorry.
Oh, you're good. I just hate. I have to like put it all in like a certain way with these calculators. I can't just put it into like a scientific,
Yeah.
walking calculator. I can just do it all at once. Okay, 0.046.
Yeah, that's what I got.
So, what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
So do we do the 0.3 minus the 0.25, or do we do the 0.25 minus the 0.3?
8.3 minus the 2.5.
Okay, that's what I was thinking. Divided by the standard deviation, right?
Oh my goodness, just clear all. Why would I clear all? So 0.3 minus the 0.25 divided by standard deviation. Oh, I don't know. So usually we just put it into our Excel sheet.
But,
But usually we just can put it into an Excel sheet.
you know. But it doesn't give us the x. We're trying to figure out what x is. Right? Did you get an answer?
Yeah, but I don't think it was right. It's like a 1 point something. I erased it.
0.87? That's what I got too. So,
Because I just found this on Chegg and it helped me see if I can show you. I don't know if you can see.
oh yeah. Oh, so you do the point.
Does that make sense? So I was trying to look at and what to do.
No, it has I got the 0.138. Oh, wait, just a second. I might get it. Okay. I think we have to put this in the applet now. At least I'm gonna try that.
Finally found one that like tells you more about it instead of just giving you the answer.
And what did the answer on Chegg say?
0.138.
Okay, so we do the 0.25 minus 0.3, which gives you a negative 0.05, and you divide it, which gives you a negative 1.087.
Okay, that's what we were doing.
Put that into the probability applet, and since it wants less than, you only highlight the left side. And then you look at the area, which is the probability, which is 0.138. 85, so round up would be 89 or 0.139.
Okay. 0.139.
I forgot about the probability applet, so.
Yeah, so that's the next step we're forgetting, probability.
That makes more sense because I thought that was really high. It's like that's over 100%.
That's why I was like, why is it a 1 point something? Like that can't be right.
I don't know, but that makes more sense. Yeah, put it in the applet. Until I don't study my homework all week.
Yeah, no.
Okay, that makes more sense.
Okay. 15. I don't even know what this is. Acupril, what's a type, is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1,536 1,560 3 subjects in the experimental group received active role. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in control group, 15 experienced dizziness as an effect. Let P1 be the true proportion of people who experienced dizziness while taking Acapulco. Let P2 be the true proportion of people who experienced dizziness but did not take Acapulco. Okay, so we have enough to put it in an Excel sheet.
Yes.
Let's see, this would be the 2 proportion. I have to look at them again. Would it be the paired?
Yeah.
Okay. Get that Excel sheet. Hmm. I'm sorry, it's just taking me a minute to get it all in.
No, you're good.
So how would I do this with it when it doesn't give you the? I just do 1,563 compared to 579.
Yeah, so your X1 is 61 because that's the number who felt dizzy.
Okay.
And then your N1 would be the 1563. And then your X2 would be 15 because those are the people that felt dizzy.
And
And
then
your
it would be
579.
I was on the wrong one for some reason.
Oh, you're good.
Okay, confidence level. Now I need a lesson. Because it want us to go. Why does it saying P1 minus P2 like the P1 hat?
Um,
About?
I don't think that part's important.
Okay, I was like, probably found in the past. Okay, so for your confidence intervals, did you get 0.317 and 0.372?
No.
I thought that was wrong.
So wait, what's your X1?
579.
Oh no, your X1 is 61.
Did I do these backwards?
Or you're still sharing your screen? Sorry, I'm not looking at it.
Oh my, I did it wrong. Because it should be 61 and then 15, huh?
Then for the 15, 63, then 15, then 579. Just going down that input.
Okay, so now I got negative 0.003 and 0.029.
Yep.
Okay, good. Sure. Thank you.
Yeah, no problem. I'm gonna run upstairs real quick while you calculate the margin of error.
Okay.
Okay.
I'm just on number 18 now.
You're an 18?
Mm-hmm.
Okay, so for 15, what did you get?
0.016.
Okay. And then we just input the other two. Okay.
So like negative 0.003 and 0.029.
Yep.
And then I'm thinking for 18, that I have come to a conclusion of would be the first one, I believe.
Yeah, that's what I put.
Okay. So the value of your test statistic.
1.458.
Test statistic is the p-value. Is p-value the p-value?
Yeah.
So like 0.928.
What?
Did you get, is your p-value showing as 0.928?
What does your type of test say?
Choose sample.
Oh, no, sorry. Under confidence level, what does your type of test say? P1.
Oh, it's greater than.
So change that to not equal to. See what you get.
0.145. That's not
Okay. That's what I got. And I was like,
why is that so high? Okay. There is sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acapel is different than the true proportion of the people who experience dizziness.
so the P was high, so we failed to reject the alternative hypothesis.
So, like, no, I failed to reject.
It's either that one or yes, I failed to. So let's think about this. So if we fail to reject the null, that means we accept it, which means that they are equal. So it would be no, I failed to reject.
The last one.
Yes, sorry, I have to talk myself through it. This one's the chi-square. Next one is
Chi-square because of the grid.
what? Let's see.
So, I'm a night person. That would have been a cool one to do. Speaking of which, we need to figure out how to. We're gonna have to meet sometime and go through all our data.
Yeah,
It's
or
gonna
if you want,
have to
I can just go through it all. I opened the document that we're supposed to submit, and like it just says restate your question. Then provide a short summary of what each group member learned while collecting your data. So I mean, everyone should look at it, but I can summarize it and put it all into an Excel sheet if you want.
Okay.
Because I feel bad because I probably won't be of much help on my honeymoon. So I can do like the majority of this, and then it says provide a short summary of what each group member learned while collecting your data. Describe where and how you collected your data. Was there a situation you had not anticipated? How did you handle it? Well, I don't think we anticipated people to keep writing in the word divorced and stuff.
Yeah.
So how did we handle it? We just categorized it ourselves. Use complete sentences and be coherent in your writing. Then attach the data you collected. And then describe the data. Says use 2 to 3, or use 2 pages. And then in 2 to 3 paragraphs, using summary statistics as well as other descriptions. Provide an overall picture of your data. Include a well-labeled graph.
Oh man, we all have to submit it, or just like.
Just one of us, I believe. Yeah, I think just one of us has to submit it. Whatever your document you just sent me said at the top.
And study.
Oh, never mind. It was the other one then. I think Cal submitted the other one. Whatever. I think only one of us have to submit it.
Okay. I think I was the only one who submitted that one, right?
I think the only one that we all have to submit was that quiz thingy.
Mm-hmm.
We all have to submit that, and then at the very end, like when we evaluate the group or something like that, we have to all submit it.
Oh, okay.
But I think these other portions, you designate a like team member to do it, and then that person submits it. I think the next part is we have to put it into a like PowerPoint presentation or something.
Okay. And I have all the stuff inputted for this next 22.
Okay, I just finished.
Okay.
Calculate this test statistic.
Mm-hmm. So I think it's 6.579.
Yes.
P-value to 0.866.
0.87.
Are we supposed to run it to 2?
Oh, sorry, 0.087. Oh wait, no, there's another zero there. There is another zero there.
Oh, yeah, 87. Okay.
Sorry, my zeros and my decimal were looking a little fuzzy there for a second.
You're good. So 0.087.
So the P is still high in comparison to the 0.05. So we do not reject.
So like no, the p-value is greater than the 0.5.
Yeah, so that's like option 4.
Yeah. Mm-hmm.
I said we're over halfway through now.
Oh gosh, I'm gonna be way late to work. I guess I won't shower before. It's fine. It's only half.
If you need to go, you can.
No, it's fine. Really, I'm fine. They know.
You're like, seriously, I don't want to go anyways.
I mean, I wanted that to get time and a half. I mean, that would have been like $20 sitting there for another hour, but it's okay.
Yeah, that's true. What do you conclude based on your results?
Independent by age, I don't think it. We have sufficient evidence to say that being morning or evening person is independent of age. I think it's just all in your personality.
Oh wait, so wait. What were our hypotheses? So we rejected the null, or we failed to reject the null, which means we accepted it. So we have sufficient evidence that it is independent of age.
So the second one. Right?
Yes?
I think so.
This confuses me so much.
Let me see.
Hey, are you ready? Sorry, are you ready?
Yeah, I'm ready.
A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that have graduated from one of the top 10 business programs in the country were followed over a 5-year period. The 50 of these outperformed the Dow Jones Industrial Age. Let P be a true proportion of the investment who graduated in the top 10 who outperformed. Okay, so isn't this just a one proportion thing then?
Yeah.
So we do 250, like 50 be our X,
And 200.
be our sample size or N.
Yeah.
Then it says put in the upper and lower bounds rounded to 3 decimals.
Like the 0.310 and 0.190.
Yeah.
Suppose you had been in charge of designing the study, what sample size would be needed to construct a margin of error of 2% with a 95% confidence? Oh, interesting. I have no idea how to do this one.
Let me reread it. Okay, so if you go back to lesson 17, at the remember part, the last bullet, I think, helps us.
So is that like the 2 or the z over m kind of thing?
Yeah. So n would be 0.02. Or z, wouldn't that be the 1 point something something? 1.096 or something? Let me look at my notes.
Yeah. 1.6.
1.96.
Mm-hmm.
Okay. So yeah, I think we just put it in there. Calculate it that way. So it said our p was point what?
Or p?
0.2. Yeah.
Oh, squared. Okay, that doesn't seem right.
What'd you get?
Like 2,151.
I got 1,536.
Well, in all honesty, that's what Chad got. What did I do?
So did you do the 1 minus 0.2? You get the
Mhm.
0.8 times 5.2.
Yes.
Gives you a 0.16. And then did you do the 1.96 divided by the 0.02?
0.02?
Because it's 2%.
I did like point, I think I went 0.02. Okay, that's it.
Yeah, so 0.02. And then square that. and multiply that by
1536.64.
Yeah, so would you round up to a whole person? Because you can't
Yeah,
have a sample size of 0.64.
yeah, I think you'd go to the 1537.
Yeah, because if you did 1536, it wouldn't quite be 2%.
Yeah,
It'd be 2 point something percent margin error. So 1537?
yeah.
Okay.
Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Okay. Mhm.
So the first P would be equal to. The other one would be P is greater than.
Then,
It's like second from the bottom.
yes.
Okay. The next one's the first option, right?
Mm-hmm. Yeah, that's right in that 17 remember box.
For 30?
Mm-hmm. Isn't it?
Yeah. Or if the sample size is larger than 30, though, technically that is a qualification as well, but I think it's asking for the top part.
The value test statistic. Ooh.
Did you get negative 13.887?
Yeah.
Okay. Try that.
Seems weird.
Huh?
Seems off.
Yeah, it does.
And I have greater than, right?
Yeah.
Should be, yeah, it should be greater than. Doesn't teach the test.
Yeah, it doesn't change it, so.
Okay. So then the p-value is 1.
Yeah.
It seems weird too. What? I don't know. 1 seems really off. I'm trying to...
Right? And I guess if it's wrong, we can redo it, right?
Yeah, I'm trying to look at.
Check.
Yep. See if there's anything that helps us.
Hey, I get married in 10 days.
That's so crazy.
No.
Oh, it's really crazy.
That means the semester's almost over. Did you know they're preparing to take their state lit tests?
Oh, for real?
Uh-huh.
Yes. We are almost done.
Also, you're student teaching this winter, right?
Yeah, it's due on the 10th.
13th.
Oh,
What?
13th?
That's what the student place office told me.
Okay.
Field services
I
when
thought
I was there.
it was the 10th. So let's just get it done really quick.
Yeah. Yeah, because I remembered that it was the day before my wedding.
Oh, this is what I at Chug has. Can you see that?
Once I open that screen. Oh, can't see it very well though.
Okay, what did I do last time? See. Oh. No, I'm trying. Okay, can you see that?
kind of. Don't understand. So, huh. Don't know. So yeah,
I don't really
I
understand.
don't understand it.
Okay, I was trying to understand it. Yeah. Let's just go with it. I'll probably have to redo it later.
Oh wait. I'm gonna try something. Okay. I know how to fix it. So what's your null hypothesis say?
0.07.
Okay, it's 0.2. Because that's what we literally just said in like 2 questions above it.
Oh man.
And it makes a lot more reasonable sense.
Okay.
Not negative 13, it's 1.768.
That is like so much better.
I know, I was like, they've never been that high. Shoot.
Or negative like that. So the
Yeah.
p-value is 0.039.
Yes, this is a lot more comfortable feeling.
Good
So
thing.
the P is low, so we reject the null. Is there sufficient evidence to conclude that the graduates from the top 10 businesses perform better? So no. Wait. The null is that they were equal. The hypothesis is that they were greater than. So if we reject the null, it means yes, because we rejected that they were equal, so it must mean that they're greater. So the first one?
Yes.
Sorry, I really have to talk myself through those, and even then I'm wrong half the time.
Good. Very good.
Wow, those are lots of words.
I'm not. Let's just read it out in our mind.
I hate when it tells us about the stupid thing. I'm like, I don't care. Don't tell me. I don't care about who this PhD is. Wait, so are the people like out selling the bug spray or whatever you guys are there for? Are they doing that today?
They do it for like half a day because they are able to do it for a really good price. There's like a deal.
Oh, okay.
So they do it for like a little bit, like between, I think my husband's working from 10 to 2, so he doesn't like intervene with any like barbecues or anything.
Okay, that makes sense. He
He's done,
just has to worry about parades.
yeah, I'm trying to do the parade. He's done it the past 2 summers, and people are usually pretty nice for the most part. He actually has gotten a few sales
That's good.
on those days. I don't know. Wouldn't appreciate it, so
Me
I
neither.
don't know.
I wouldn't want to do it.
So I just have to go to work cause when they get sales or something, I have to like make sure the people who come and spray know they can go out and spray if they need.
Huh.
That's why I have to go to work. I don't think I'll be getting any customer calls. So we need to enter everything in.
Wait, what are you putting it into?
That's what I'm looking at right now. Is it just like a one sample?
Oh yeah, I guess it would be. You're right. One sample t-test.
Yeah.
Yeah, that's it. Okay, don't screw me.
Put the lower bound. Oh man, I have so many open. Like a 0.282.
That's what I got. And 0.293.
Mm-hmm. So calculate the degrees of freedom. So degrees of freedom is n minus 1, right? How many do we have? Oh, 100. 99? Oh yeah, it's right there. Right?
Yeah.
Okay, and the t statistic. So should this type of test be
Not equal.
yeah.
And when in the null hypothesis, we put in the 0.295 right above that.
Oh, instead of the 10, mine's at 10 for some reason. So 0.295.
I think so.
I get the negative 2.803.
Yeah. Which that's not unreasonable at all.
No.
But negative 13 is
Yes, it is.
803, not 903. Wow, we're on 38. Yay. You put the p-value 0.007.
P-value 0.006 is what I have.
691544.
Yeah, so 0.006091.
Oh, I thought it was 69. My eyes are not seeing zeros right now. You're right, 0.006. My eyes are struggling with the zeros.
Oh, you're good.
Based on the results of this test, what would you conclude? P is low, so we reject the null.
If it's connected, we have sufficient.
You want it to be the first one?
That's what I was just thinking. Rejected or definite.
I think too.
Okay, I put this one in. Okay, so this is the
Is this one the paired sample?
sample, yeah. I feel like we've done this one before.
I feel like sometimes they do repeat themselves.
And the type of test is it like a greater than? Is it taller in the morning than in the evening?
What?
What type of test would it be? Would it be something that maybe greater than?
Oh, what's our question? Yeah, taller in the morning, so it would be variable 1 is greater than variable 2.
Okay, I have my upper and lower bounds. Lower bound,
Okay,
I have 8.728.
yeah.
Upper bound 10.455. Test statistic 22.446.
That's what I got.
Use of freedom 40. .397 for the p-value.
Yeah, I think
Little
I had switched it because I was confused by something. But but that's scientific notation.
Mm-hmm.
So is it just the?
Be careful scientific notation, especially in the p-value cell in the Excel spreadsheet. Okay, so I'm reading that. Law of large number. If the sample size is large, the sample X mean will likely be close to a population. Well, I don't know what that's supposed to mean. Which Jesus says, be careful with the scientific notation, especially in the p-value cell in the Excel spreadsheet. And the exam. Hmm.
Should I take it out of scientific notation? We could just put that p-value in, and then if we get it wrong.
That's what I'm thinking.
One point. Or would it just be 0?
I got 1397.
Okay.
So that is definitely higher. We failed to reject. No, because we failed to reject the null. Right with 45 is the first one.
What?
I'm looking at 45. It's higher, p-value is higher, so we failed to reject.
I think the p-value would just be 0. Because I think it's 0.00000, that number, because it's to the negative power.
Did you took it out of the scientific notation?
Yeah.
Well, that would make sense. Let's try it. She said to be careful. So then
It
it's
does.
less than. No, it's still greater than.
The p-value? It's less than the a. So the p is low. So we reject the null. And the null
So
is
45, I'm thinking. Still the first one.
wait, 45, you think it's the first one? I think it's the third one on 45. I could be wrong.
Right, Kylie?
Wait, did you submit it? Hello? Can you hear me, Melissa? Hello? Hello?
Okay, I need to go. So I can get.
Did you submit it?
I'm 1 hour late to work.
Did you submit it?
Can you hear me?
Yeah, can you hear me?
If you're talking, I can't hear you at all. Oh, did you submit? Now it's working. I can hear you.
Okay.
I'm like,
'Cause I
hi.
couldn't hear you for a while either, and I don't think you could hear me for a while.
That was weird.
And I was like, hello? Hello? Did you submit it?
No, not yet. I just want to make sure that last 145 wouldn't be, it's low, it's higher, so it's reject.
I put C for the last one since it's really low because it's 0.0000001 something. So it's lower than the 0.05.
Oh, I guess in all honesty, yeah.
So the P is low, so we reject the null, which means we do believe in the alternative hypothesis. But I can hurry and submit real quick
I
if you
just
want.
did it. I got 41 out of 43.
Okay. What ones did you miss?
Five is supposed to be independent. I mean paired. Five is supposed to be paired.
Okay.
One. 25 is supposed to be the last one. We have insufficient evidence.
25 is insufficient evidence.
Mm-hmm.
Okay.
Oh, I guess I only missed two. That's it.
Okay.
But I think I put a different one on number 2. I put the chi-square test, and number 3 I did test of two proportions. I don't know.
2, you put chi-square?
Yeah.
Okay. So for 2, you put chi-square?
Mm-hmm.
And then for 3, you did what?
Test of two proportions.
Yeah, I didn't have those. Okay.
Chase, people are here.
They're not supposed to be here.
They're here. They're trying to open the door. I gotta go.
Okay, see ya.
Bye.
Oh my
Bye.
gosh. Meeting's at 9.